In this problem, we have a gaseous reaction, and we have the initial pressures, the initial partial pressures of both reactants that react to create the product of 2CO2. And our question is asking for what is the total pressure at the end of the reaction in ATM? And we're given that the reaction occurs in a 1 liter flask at 298 Kelvin with our R constant. So there's two ways to look at this problem. One is you can use PV equals nRT to calculate the moles of both reactants, figure out the limiting reactant, and then figure out the moles of the corresponding product, and then do another PV equals nRT to figure out the total pressure of the product, which you could then backtrack and use to figure out the total pressure of the entire system. That's a little bit more difficult. But what you can do is you can use our knowledge of PV equals nRT as an equation, and I'll show you what I mean by that. So if you have PV equals nRT, in this reaction, a lot of things are constant. Our temperature is constant, R is constant, and the volume is constant at 1 liter. The only thing that changes for reactants is the pressure and the moles. This pressure and moles are proportional to each other directly. We can use it as representing an amount since we are talking about ideal gases. Using this logic is very important because we can use that to very easily solve this question. So here's what I mean. If we have our reaction, we can basically rethink this equation as instead of 2 moles, we can say 2 ATM of CO2 react with 1 ATM of O2 to create 2 ATM of CO2. That's very important for these reactions or for these type of questions. So what we're saying is if we have the initial partial pressure of CO as 1.3, so CO is 1.3 ATM, how much of product is that going to make? Since we know that 2 moles of CO2 or 2 ATM of CO2 makes 2 ATM, or sorry, of CO makes 2 ATM of CO2, it's a 1-to-1 ratio. So we know that this 1.3 ATM of CO is going to correspond to 1.3 ATM of CO2. Then for our next reactant, O2, we have 1 ATM. Looking at our pressure ratios or mole ratios, we can say that 1 ATM of O2 reacts to produce 2 ATM of CO2. This means for our O2 of 1 ATM, the product is going to be 2 ATM, 2.0 ATM of CO2. Now we can see which one's limiting. The limiting reactant is the one that creates the least amount of CO2. And since amount is proportional directly to pressure in this case, and since everything else is constant, we can say that CO is our limiting reactant. It creates the least amount of product. So now knowing that, we are being asked for what is the total pressure at the end of the reaction. So for this, we need to add up the pressures of all the reactants and all of the products after the reaction occurs. So we know right now the extent to which the reaction will occur. We know that 1.3 ATM of CO2 will be produced. So let's write this down in our equation. So we have 2CO plus O2 yields 2 CO2. And we know we have 1.3 ATM of CO2. And we have no ATM of CO, none of CO, because we know the CO is a limiting reactant and it will react to completion. Now for our O2, this is the one that is not completely reacted because it doesn't go to the end. It's not limiting. So out of this, so we know that our CO2 is 1.3, not 2.0. So we can backtrack. If based on our equation, if 1.3 ATM of CO2 is created, how much O2 is used to make it? So we can use that ratio going backwards. So it would be half. So 1.3 ATM would basically be the 2. And then to make this 1.3 ATM, it would have to be half of that, which is 0.625 ATM. So that means after the reaction occurs, you have left over 0.625 ATM of O2. Once we add all these up, we will find the total pressure of our container after the reaction occurs, which is 1.925 ATM. So I hope that makes sense. And if you have any questions, leave a comment and please feel free to like to the video and subscribe to the channel.